Lesson 3.5, Zeros of Polynomials. In this lesson, we'll look at zeros and graphing all these crazy kinds of polynomial functions we've been working with. We'll find real and complex zeros. We'll interpret zeros of a function, and we'll solve polynomial equations. When asked to state zeros of a function, we know what to do here. Always set your equation equal to 0 and solve for x. And we've done that a bunch of times. Now our factoring might be a little bit more complex. Over on the right, it says what are the zeros for f of x equals x times x minus 4 times x plus 3. Wow, that's already factored for us, so this should be pretty easy. To find the zeros, we're just going to set the entire equation equal to 0. And when we do that, that first x is just going to equal 0. That's one solution. Pretty easy. If we have x minus 4 equals 0, we would add 4 to the other side, and we would get x equals 4. There's a second 0. And then lastly, if we have x plus 3 equals 0, subtract 3, and there's our third 0. We have 3 distinct zeros on our coordinate system. Let's plot those on the x-axis at 0, at positive 4, and negative 3. Now, if that's all we know, we don't really have enough information in this form to sketch our graph. We're going to need some more information. And here's where this interval comes into play. When we think intervals, we're going to go along the x-axis. I want to have an interval on the left side before my first 0, in between the zeros, in between the two zeros on the right, and then on the right-hand side of the zeros. I need 4 different intervals. What we're looking for is a number that lets us know if our graph goes above or below the x-axis. So my first interval is going to be to the left of negative 3. I'm going to write that as x is less than negative 3. And we really just want to pick a number that fits that description, like negative 4. That would be a good one. Whoops, how did I get that in there? Not sure where that color came from. I just wanted a darker color, like negative 4. There we go. If we plug in negative 4 for each of our x's, I'm looking for a positive or negative sign answer. For example, if I plug it in for x, my sign is negative because x is negative 4. If I plug it into x minus 4, negative 4 minus 4 would also be negative 8, or negative, so negative 8. And if I plug in negative 4 for x and add 3, we would get negative 1, which is another negative. And if I take their product, meaning I would multiply all those negatives together, I would get a negative answer. That means my graph would be below the x-axis in that interval. So we're going to be down here below the x-axis, which means on the left-hand side, the graph will be falling. Now in the middle, in section 2, I'm between negative 3 and 0. For my interval then, I'm literally going to write between negative 3 and 0. Pick any number you want that fits that description. I'll pick negative 1. If I plug in negative 1 for all 3 of my x's, my first x would stay negative. Negative 1 minus 4, my second x would also stay negative. But then if I plug in negative 4 plus 3, I get positive 2. And now I have 2 negatives times a positive, which means my graph would be positive in that direction. That means it's above the x-axis, which means it's going to be somewhere up here between those two zeros. And we just continue that process. The next interval is interval 3 from 0 to 4. And you can pick any number you want. I'll pick 2. Change it up a little. Now 2 is a positive number, so for my x column, it stays positive. 2 minus 4 is negative 2. There's your negative. And 2 plus 3 is positive 5. If I multiply 2 positives and a negative together, that makes it go negative again, which means I would be now down below the graph. So somewhere down in here. Last but not least, we need one final interval greater than 4. Let's go ahead and plug in 5 and we'll see what happens. 5 itself is positive. 5 minus 4 is 1, which is technically also positive. And 5 plus 3 is 8, which is also positive. And that means it's positive for your product. We'll end up on the right with our graph above the x-axis. So that means to the right, it's going to go up towards positive infinity. It's rising. So we'll say it rises. To make this graph happen, what I'm going to do with those arrows that I drew in is I'm going to connect them up through that first, connect it up through that first 0 and find what we call a relative maximum. I'm just going to turn my graph, go through that second 0. Not quite sure how far we need to go down. We'll just try to find a relative minimum and come up through that right-hand side up towards positive infinity. So we're trying to get those arrows in there. I need to clean that up a little bit. That's pretty messy. Don't like it when it looks quite like that. Okay, so let's get those arrows back in there. We're going to fall towards negative infinity and rise towards positive infinity. That's graphing a polynomial function with 3 zeros. The next part of our lesson talks about multiplicities of a 0. When we graph, multiplicities can change the shape of a graph. By definition, a multiplicity is the number of times a 0 is represented in a given polynomial. As we look at multiplicities, you can have odd multiplicities and even multiplicities. Odd multiplicities would mean you're solving something like x to the first power equals a number. And if it's to the first power, that means multiplicity of 1. And your graph just crosses the x-axis, like a normal x-intercept. Oh gosh, hang on. What did I do? Oh, I can't get the t to show up. There we go. Crosses the x-axis. Ah. If you have a higher ordered multiplicity that's odd, like x to the third equals a number, then what your graph is going to do is kind of slant or angle through your 0. And I'll show you with a picture what that looks like. It's kind of unique. Another type of multiplicity would be even multiplicities. If you have something that's x squared and it equals just one number, that means it has a multiplicity of 2. Ooh, and I think I forgot to add that in up at the first one. Or the third one, sorry. When x cubed, that would be a multiplicity, sorry, there's so little room to write here, of 3. Write that in there. And then it does that kind of slant or angles through. If you have x squared now for an even multiplicity, that's a multiplicity of 2. That's called a turning point on the graph. Oh, and now I'm the wrong color. Boy, you guys, this is not my night to write these out. There we go. So an x squared would be a turning point of the graph. It would touch that point on the x-axis and go in the opposite direction right away. The other kind of multiplicity that we'll see would be an x to the fourth, and that's really rare. If you have something that's one solution, but it represents x to the fourth power, we would say that has a multiplicity of 4. And what that graph is going to do is kind of flatten out at that 0, or at the solution. And we'll look at all the ways these things can happen. I know they sound really interesting at this point. It says, how does a multiple 0 affect the graph of a polynomial function? Let's take a look at the examples on the right. In that first example, f of x equals x minus 1 times x plus 2. Now for that, we're going to find our zeros by setting the equations equal to 0. X minus 1 times x plus 2 equals 0. That means x equals positive 1 and x equals negative 2. So we would plot a 1 and negative 2. Notice there isn't an x squared or x cubed. Technically, those are both multiples of 1. To sketch the shape of your graph, notice that the a value, or the number out in front, is positive, which means the arrows would point up. We would know then to cross through those zeros and have kind of a parabola shape with arrows pointing up. Now to the right, similar idea, but just slightly different because now we have x minus 1 squared. In this example, to find our zeros, if we set x minus 1 squared times x plus 2 equal to 0, that first parenthesis, x minus 1 squared equals 0, you're only going to get one solution, x equals 1. Because of that 2, however, we would say it has a multiplicity of 2. And that means it's going to be a turning point. The other 0 would be at x equals negative 2, and that has a multiplicity of 1. Which, like the other example, just goes right through it. Plotting those points, we'll have a point at negative 2 and a point at positive 1. And in this graph, it's going to start on the left low, so we'll have an arrow down at the bottom. It will come up through that 0, since it had a multiplicity of 1, find a turning point, and when it curves down to that 1, it's going to go right back up to positive infinity. That multiplicity of 2 is known as a turning point. All right, let's try these examples down below. I'm going to give myself a little bit more room to write some things out, so I'm just going to make the graph a little bit smaller. Oh, that's not working at all, is it? That was crazy looking. All right, let's try that again. We're just going to make this graph a little smaller. Oh, it won't let me do it, you guys. That's so weird. Whoa. Do you see what's going on here? Oh, there we go. Wow. Okay, this has never done this before. This is crazy to me right now. Hang on. Okay, as you can see, I kind of got it all to be back where it was supposed to go. That was so random. I think we're going to call this good. So I apologize that that graph got so crazy on us all of a sudden, but we'll take a look at the rest of these multiplicities and we'll finish our notes tomorrow in class.